Hello everyone, welcome you all to the Tech Geek webinar. Thank you for joining the session today. The topic of today's talk is machine learning made easy with SAS and Python integration. It will be a 1 hour session with around 40 to 45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, please send them to us using the questions tab on the GoToWebinar control panel. I'm Anmol, the moderator of this session, and it gives me great pleasure to introduce you to our guest speaker, Mr. Sunil Bhardwaj. Sunil is presently working as Senior Analytics Training Consultant with SAS India and is a certified data scientist. He has 14 plus years of training, mentoring, and consulting experience with SAS with all the leading clients in India and abroad. He has conducted mentoring workshops in the area of business forecasting, predictive modeling, big data analytics, operations research, and design of experiments with leading corporations in the area of banking, retail, manufacturing, and agriculture. So without any further delay, let me introduce you all to our guest speaker. Over to you, Sunil.
Thank you, Anmol. So hi, welcome once again. We'll just now dive into the webinar. This webinar is largely focused towards machine learning. We're going to see the concept. I'll take you through the agenda. So largely what we are going to do here is we're going to talk about very quickly about the machine learning overview. I'm going to discuss some of the very basic ML techniques that are there along with the industrial applications. We're going to see a demo on SAS tools, how these ML applications can be done, and along with how you can leverage your Python knowledge into the same. And a few things towards the end I'll discuss, where you can get more information, knowledge on the machine learning side of it within the SAS world. So let's begin with that. Now, before I go further, I would request a little poll you have to answer that would help me to phrase my sentences in the webinar. May I request the poll to be up?
Hi, Mr. Sunil. The results are displaying on the screen.
Okay, great. So thank you for the poll. So let's move on now. What I'm going to do is to talk about the machine learning. So you might be aware of how the machine learning has made waves in the recent years, and there are a lot of surveys coming from several of those organizations, research organizations, academic institutes, job portals. So everywhere you see that the machine learning usage, and in fact machine learning as a service option, is going to generate a lot of revenue. These are some of the estimates. Most of the things you see, North America, Europe takes the lead, but Asia Pacific is also just gearing towards it. And most of the work comes to India by the way of outsourcing. And you can go to any job portal, search yourself. The demand for machine learning jobs is on quite high. MIT Sloan surveys shows that how the focus of organizations, most of the organizations is going towards the uses of ML. In fact, machine learning has gone to an extent that both Stephen Hawking and Musk has warned the people, that machine learning machines will take over the human world. We would have a situation we see in Hollywood movies, like the Terminator kind of a thing. So the two schools of thought. One says the machine learning will take over everything. The other one, okay, the things will remain as it is, only it will be applicable only to certain business operations and certain technical operations. So we don't know the answer right now, but of course the trend, all the trends across, we see that we are unleashing an era of machine learning. Now, quick definitions. Now, what is machine learning? So very quickly, I would say that it's a subset of AI, and it automates the very process of model building, learning through patterns, making predictions based on the past data. And as we speak, the human intervention is getting lowered in all the processes, and computers will take most of the course of action that goes into deciding and designing the machine learning applications. In fact, machine learning is an old concept. SAS CEO Goodnight, around 30 years ago, he wrote a machine learning algorithm. We call it K nearest neighbors. Well, machine learning is of several types. Supervised learning, in fact, there we have basic types like regression, decision tree, and neural networks, along with new things getting added, SVM, naive-Bayes, Gaussian processes. We have unsupervised learning, which talks about clustering, factorization, PCA, SVD techniques, and many others. We also have a combination which we call semi-supervised, and as we speak, the field is evolving into several other types of learning that we see. So machine learning, it has become important now, and each aspect. So the data guys, they have a lot to do. Data is all spread over whether it is structured, social media, online, device data is going to get collected, and there we need people, mechanisms, processes that can harness the data. So a lot of opportunities in the data area itself. Computing power is increasing day by day, and that market is also going to grow, along with obviously the people who use or write algorithms. They would be in the greatest of the demand, because they are the ones who convert everything to a given application. Well, machine learning has its own process. Any statistician would agree this is the generic process that we have for anything, but the terminologies we use are slightly different. We fetch the data, we have to pre-process the data. Whether we use specialized tools or we write your own algorithms, the choice is us. We have to pick up right features, basically the input variables that goes into my machine learning. There has to be a suitable learning algorithm, and that's where most of the action is happening. We see a lot of these new algorithms getting developed across the labs of innovative companies, universities, backyards, a lot of these things. Now, once a suitable algorithm gets applied, we just validate it, we'll see how the results are, and then the results are deployed. So this is the typical process that is followed in any machine learning initiative that we have. Having said that, where do I apply the machine learning? A lot of applications. Banking, for example, NBOs, credit scoring, stock markets, several agencies, financial world, detecting fraud, marketing. It could be used for customer segmentation, online recommendations, anything to do with target acquisition, retention, and nutrition of customers. We use that. In fact, the real-time ad placements that you might have seen recently is an act of machine learning algorithms. We talk about NLP, computer understanding human languages, deriving out a lot of valuable insights, chatbots. These are all the underpinning or the underlying technology. We can club it as machine learning, apart from many other applications, including network intrusion and much more. The context was machine learning made easy by SAS. So SAS has its own benefits, open source has its own benefits, and we try to marry both of them to get the best advantage when it comes to a commercial side of it and an open source side of it, and we can have the benefit drawn to us. Well, there are a lot of things that we can talk about. Few things when we talk about SAS. The way the machine learning algorithms can be deployed, the speed is one of the characteristics, data encryption and security is other. Along with that, SAS softwares come along with service level guarantees. So we're going to marry both the worlds and see how the best can be taken out from the journey that we have. Well, the machine learning advantages in SAS is the capability to automate with a higher speed, ability to customize on top of it, and the speed. So three things: the automation, customization, and speed are the hallmarks of machine learning when it comes to the SAS world. We use typical tools to do machine learning. One of the tools that is used It has a UI interface, easy to use, has all the capabilities for all the processes of machine learning that we have discussed. And this tool can be deployed with the greatest of ease in any industry or any application. So machine learning, what I'll do is, I'll just give you a quick overview of generic techniques and some of the applications. Then we'll go to the demo side of it, how these things can be plugged, and how do we actually do the machine learning. Well, there are three primary techniques which are generally talked of: decision tree regression and neural. By far, they have been the largest deployed techniques worldwide. Very quickly, I would say that the decision trees is one of the basic techniques and very easy to comprehend and understand. So you can do predictions with that, and it looks like as if a tree is flowing downwards. There are split search that is done to predict anything. The example here is you want to predict yellow versus blue. So there are cutoffs. X1 and X2 are each of my variables. The CART algorithm identifies the split points based on the log worth. Either of the X1 and X2 is picked up. The point at the maximum log worth becomes your split point, and the algorithm slowly develops, and it simply identifies yellows from the blue. They're just an indicative examples for that. And the EMinor, the tool that I was just talking about, would pick up the best model in the validation, so it all automatically happens. It creates a largest tree, keeps on pruning it and assessing it at every stage, and it takes up the best tree to be applied for the production deployment later on. So we validate while we create the models. Likewise, for regression, I think it's pretty clear to many of us that it's a simple case of an equation. It could be a linear regression depending if my y is continuous, or a logistic regression model if my y is dichotomous or trichotomous. So we use a logistic regression model. Each of them, either we are minimizing the error function or maximizing the log likelihood function. And a series of model is created through stepwise selection. And the step that gives me the best characteristics in the validation could be the average square error or the misclassification rate. It's picked up for further testing and deployment. Similarly, neural network, which is based on the functioning of our brains and the neurons, that can also be deployed. The whole idea is to get an equation which is far more complex than the regular equations that we have, but at the end of the day, it will give me the predictions that I'm looking for. So this is an example of a neural network. So you have at the front a logistic regression model running. Let's say if my job was to classify, but each of the columns H1, H2, and H3, they are derived from the inputs to my machine learning model. So you have terminologies like input layer, hidden layer, target layer, activation functions. Now all that has to do with the similarity to the functionings in the brain. But at the end of the day, for my machine learning algorithm here, it's all a set of complex equations. So we train the neural network model, pick up the best, which has the least error, let's say in the validation or the misclassification rate in the validation, and we use that. Neural nets, they're universal approximators. You use it for supervised, unsupervised, or a combination. They're typically very, very versatile techniques, could be deployed even for forecasting. So there are some advantages of neural nets. Well, neural network applications, if I have to list them down, I think even 1 hour will be not sufficient for that. So it has applications, as you can read, in the chemical process industry, in the oil and gas, marketing, let's say newspaper sales, automobile testing, welding testing, handwriting analysis, fraud detection, water supply, image recognition, online quality modeling, sales and retails, quality assurance efforts. Furthermore, chemical, applications, right? Anywhere you talk about, I mean, this list is so wide, and the applications, these are some applications I have listed where we have seen the light of the deployment. Well, these applications are so overwhelming that it is too difficult for me to put, on a webinar. But then the length and breadth of all these applications might have indicated you that how versatile the usage and the applications of machine learning are. Well, having said that, let me do a quick demo on one of the basic tools. So the context here is that we have a data. There was a retailer who wanted to see how the customer behavior is. So organic products were kept on the shelves and the loyal customers were picking them. The data was recorded. The study was done, let's say, on a pilot basis on some 22,000 customers. Now, based on the data, the client wants, or let's say the researcher wants answers to certain questions like who are the potential customers? Can I find out the propensity of a given customer? What is the probability that somebody would buy the product or not? What could be the segments or what kind of an advertising strategy one should adopt if they're looking for such kind of application of machine learning? So we'll see that machine learning can answer most of these questions that we have. So let me take you through a demo. Let me also introduce the tool. And let me show you how we do it. So I'm going to a tool called SAS Enterprise Miner. So you've got login first and you've got some projects. So what I've done is I've created a demo project already. So I'm entering that project. I've got some here. So we have to bring in the data sources first. That can be easily done. Then we do it in terms of a flow chart here. So I'm just going to show you a diagram or a flow chart that allows me to do machine learning on a coherence basis. We have something called a SAMA, that is sample, explore, modify, model, and assess. That is the underlying theme of doing machine learning with SAS EMinor tool. Each of these are different algorithms to draw your samples, explore your data using different techniques that we have. These are set of algorithms which you can drag and create your process and get the results. So under modeling, you have all the models present, things like regression, neural network, memory-based reasoning, and many, many more. So there are like 12 of them there, and then you have random forest, gradient boosting, naive Bayes, all these algorithms. So how you proceed in this one is to, first, let's say, drag the data, for example. So I have the data going by the name organics. I would drag it. Then if I want to explore it, I might use one of the algorithms called DMDB. So you attach it and you simply right click and run. So all the codes and everything else would be already there. And the moment you start running it, it starts the processing and one by one your results starts to come in. So this way, what I've done is, as these things are running, I have already created the entire process, which has done feature engineering, feature selection, built models. So let's say organics was my data. I'll take you through very quickly what the data we are talking about here. So this is the data where we have that experiment done. So it has several features like the age of the customer, affluence grade, gender, region, loyalty status, total spend. And then we have the purchase indicator, who did buy the product and who did not. So that is historical. There are some 22,000 rows that I have. And based on that, I'm going to create a model that can give me the predictions. What are the probability of each of the customers in the data? So I partition the data. I do training and validation. Now, I see that there were issues in the data, like I had outliers, I had skewness and kurtosis. So I used transform variable functionality from the modify tab. There were missing values which I imputed, so I've used the impute, and then I ran regression, neural network, and let's say decision tree analysis. All of them were dragged from the model here. And typical results, for example, if I see my decision tree, you got the results. And here, if I were to specifically answer some of those questions that were there, so I see that initially my buyers are 24% and non-buyers are 75%. Now that's my full basket that I have. If I see the first cut, the algorithm tells me that age can be one of the differentiating factors you have. So the age based on the log worth and the CART algorithm has two cuts. So you look at the people who are more than 44.5 years of age and less than that. So if I were to see this segment, I see that in the senior age group, if I call it 44.5, only 15% of them are buyers. If I ever go to the other side, I see that 51% of them can buy. So this segment is obviously more workable. So I can focus on the young people. Within young also, I can see what's the affluence grade and gender. So if I see this segment, These are the female segment of affluence grade more than 9.5, age less than 44.5. The chances of selling the product goes as high as 80%. So that way, I can keep on scrolling and scrolling through this tree and figure out what are the best combinations that might be there for me to look for the segments I'm looking for. In fact, a lot of things that this tool can do is to, talk about these node rules separately of simple plain English, that how your chances would vary. For example, look at this node 19 or the segment where gender is either you are missing, age is less than 44.5, and affluence rate less than 9.5. You have only a 13% chance of buying it. So I might ignore this segment. So I can look at the numbers of the segments where I find my one being higher than 0. So let us say node 28. I have a 76% chance of selling the product, wherein if the gender is any of those, you am missing, age is more than 44.5, and a range of a typical affluence grade. Similarly, I can figure out and just scroll through that, and I can get my best rules. In fact, these rules, I don't even do that way. The software lists what are the best possibilities happening in terms of the output that I get. So I have a segment where I can sell 82% of the customers are buyer in that. So that way this analysis can keep on going that way, and I can figure out all the answers that I require. I have all the prerequisites that I need to do the models. Now that is one of the models which I just talked about, decision tree. Similar analysis, neural networks, obviously the explanations won't be there. If I want to see the equation, I can go to the regression analysis. All these three models can be compared with the node which is available under SAS. So everywhere when I get a data, there is no single rule which says either this method or that method is better. So all the methods are compared, and you can say based on the average selection criteria, validation average error, I have tree 2 which is the best. I get to see all the other numbers, Gini statistics, K statistics, ROC index, and all the other things that a typical industry might need. And the best model is selected. Finally, I have my database of customer. I call it scoring data. These are the customers which I haven't used in the pilot study, but still I can find out what would be their propensity to buy. So I plugged in the data. The best model is kept here. I use a scoring facility under the assess notes. I've dragged it from there. I attach it and run it. And what scoring does is, if I were to quickly show you, I've just done on a sample of customers which were not part of my pilot study. Those are, I think, 5,000 or so in the number. What the system will do, since I have their features, the system is going to give me how much of a probability is there of each of them buying the product based on the very best model that I picked for that. So if you were to see this, if I go to the end, I get the probability of buying the product. I can sort this data in the decreasing or the increasing order by just few clicks, and I can comment what are the customers who have the highest propensity to pay or to buy my product, and I can do this way. So something what the software is doing, I have all the probabilities. I can export the data to any other tool like Excel or something, and whenever I'm ready, I can use this list with all the probabilities predicted. And generally what is done is you pick up the top decile or 2 deciles of the best customers who have the highest probability to buy the product, and that's where you go. So that is just a small demonstration, and you see it's all drag and drop, and you get to customize each algorithm by changing the properties at the left hand side. Nevertheless, you can write a code also. If you're an ardent coder, nobody stops you to write a code. This tool also got a code program editor where you can write your own algorithms or any kind of a code that you want to write. You can do that. Now that is one of the demonstrations that I thought I'll give. Now remember what the title was, the marriage of open source, let's say Python with SAS. So let's spend some time on that as well. So what I'm going to do is I'm going to talk about the Python software for a while, and we want to marry the best of both the worlds. So typically we all understand Python is a general purpose language, and it can be used for almost anything, starting from web programming to UI development to software development or to system administrations. Now for scientific machine learning process, I've just listed some of them. There are packages like NumPy, SciPy, Pandas, Scikit, Matplotlib, and many others. So we can leverage that. So what SAS does is SAS makes a connection with the Python, though of course it's an indirect one, and the data gets exported, let's say as CSV, so that the Python can take in. The SAS issues the command, and the Python runs it, and SAS imports back the model, and you can productionalize that model within the SAS framework. So that's the benefit. As you would know, SAS is very good at handling large sizes of the data at production level servers with all sorts of data encryption and security. So you still leverage the Python's availability, certain packages, or let's say your team of coders have skills in Python, still it can be deployed in SAS. So that's the generic process that you need to follow. The data gets exported out of SAS, the Python runs the analysis, and the model is imported back into the SAS along with the data, and then it can be deployed. You can, use it for any other purpose, any kind of visualization reports you're looking for. So you're marrying both the words that way. Few things that whatever scientific packages you need, they have to be installed. The SAS and Python both have to be on the same server. Similarly, all the scripts that you're running, it should also be on the same server where you have deployed your SAS Enterprise Miner. So what I'll do is, I'll give you a demo of that, how it can be done. So before I do that, I'll just introduce another machine learning technique, which is just a derivation out of the decision tree. We were discussing something called as decision tree a few minutes back. Now, what if I were to have a lot of trees and take a collective opinion of each of those separate machine learning techniques, and we would have a collective argument? So what it means is, let's say you got a typical row in your data and you're predicting the probability. Now, one decision tree predicts, and you might run thousands or hundreds of them or whatever number you like, and each of them would have the probability predicted. And what a random forest would do, it can either, if you are predicting the probability, you can set the tool to calculate the average of all those trees in your forest, or you can do the voting if you're classifying them as 0 and 1. So it's like taking a collective decision, running an ensemble model over the same data by having different types of trees that you have. So essentially what it does is, a single tree would have its own way of finding out, but the algorithm runs different types of trees using different combinations of variable at a given point of time, and you can set the algorithm to pick up what is desirable. And it also perturbs the sample every time so that you get different shades. And once it is done, it keeps on doing it. And what we realize that if we average out all the findings, we are far more closer to the truth than the other. So this is the beauty of random forest. It's like taking opinion of all, kind of wisdom of the crowd. And that's the basis of the technique called random forest that we're using over here. Now, having just introduced what is random forest, it's basically but multiple trees predicting the same problem, and then finally we are taking a combined opinion of all the trees that are there in the forest, and then we're deploying it. So what we'll do is I'll show you a typical demo that how this situation going to look like when I use SAS for the same thing. Maybe I also use R and also use Python for the same thing. So let me take you through that demo as well. So what I'm going to do is to go to the tool that I have. So here I have Enterprise Miner. So in this EMinor, we have a data that we have used, and we are using the same process flow as I discussed. Now this time, this is a data on donations, and we need to predict the propensity to donate. We have the similar kind of a data. So if I were to just give a quick overview of the data, the target variable is in the last campaign who donated or didn't donate. And there are a lot of features that might impact that behavior. So we did the data partition, we did the imputations, we consolidated the data. And finally, when the data is ready, I'm ready to talk about the combinations or the, just give me a minute, I'll just scroll it up a little bit. So here I'm going down. So you see, what we've done is SAS allows you to write Python scripts, R scripts within the framework that we have. So all you need to do is to, have a functionality in SAS which we called the SAS code node. But here in this SAS code node, you can drag and you can rename any node. So what I've done is, if I have to just show you the data export, first the data needs to get exported out of SAS. So we have just written a set of codes over there. So I'll just show you a code. Maybe Python guys would love it, what it is. So first few things that I'm doing in the code is I have the data. Let me open the code editor for the tool. So here we are using some parts of SAS programming, and we are sending the data outside to the Python CSV files. Meanwhile, I've used the SAS code to introduce dummy variables, as Python does not support directly character variables to be used directly. So once that data has gone to the required place, I'm issuing a Python call from SAS. So this Python call would actually invoke the right kind of Python codes that I would have written using the random forest that is available under scikit-learn package of the Python. So typically, this is pretty much standard Python call that is there. So you are defining the directory, you are defining the Python execution code, you are referring to what Python code should be running, you're calling up the Python using SAS programming, and that is the place where the SAS passes on all the commands and information for the Python to run. Once the model is ready, we import the data, and my Python model is now imported into SAS. Once that is done, I'm now free to compare and how the Python performed, or how we did, we can run R codes, for example, in the same thing. In the same way, I can deploy Java codes same way. So it's a platform which is kind of open to all. And ultimately, if I want to compare, I can see that my Python model has run. The predictions have come from the Python, and the appropriate statistics have been picked up. So this is your HP forest model by SAS, this is random forest by R, and this is the Python forest model. They're pretty close by, but we are actually kind of comparing them to the finest degree of the fourth decimal place or something. So we can see that totally how the Python is deployed. Now the thing is that whatever is done in the Python, you got it here available as if it was a SAS model, and everything else, like I can see, open the data, I can see the predictions done by the Python, I can see other characteristics by the Python. I can also create additional extra graphs that are gonna be created by the Python, and it can be absorbed back into the SAS world, and then you can go further from there. So all happens, we have in the utility, if I were to show you, we have used the functionality called open source integration. Now that's the node that I use for deploying R code or any other code. So it has this code editor. You can put R codes over there right now. For example, it's for R. Then you can invoke a Python command from there, and you can run it. And this is what I have just used it. I have just renamed it to Python forest, or let's say the Python call and other things. So that way you use this particular node to do the integration of Python capabilities along with SAS capabilities. So it's kind of going to be a killer combination if we have the power of both the worlds. So that is what we have. Now, a few more things that I would talk about machine learning. SAS is introducing SAS Wire. It's already there, and it is coming in a big way. Now, this is an open cloud-based program. The product you saw, SAS EMinor, it's either a client or a server client. But SAS Wire is all the options put on a cloud. So you have any type of programming language. Still, you can be a master user of SAS. So you could be a Python guy, could be an R guy, or a Java guy. So these Python codes can be imported into something called a SAS Wire, and you can run your codes. Essentially, the whole objective of SAS Wire is to provide openness to a variety of the programmers throughout the world, So you could be a Hadoop programmer, you could be an R guy, Java guy, Lua, or let's say the Python, that is the context. And when you do that, you essentially end up leveraging your team or yourself, whatever knowledge or whatever programming language you have, you can still be deploying it in the SaaS environment or the SaaS world. And that way you can have best of both the worlds. In fact, all these tools that I'm demonstrating, you can try for free. Here is the link that I have just provided here, and if you are interested, you can try it out. Just provide your simple name and email, and your trial would be ready for you. The SAS Wire tool would be again very easy to use. So if I were to talk about, and if you just give me a minute, I'm going to introduce how the SAS Wire machine learning would look like from the SAS Studio specs. So this tool is just a very user-friendly tool, and the tool that I'm going to show you would simply be easy for programmers or even for the non-programmers, and you can connect to the SAS cloud and you can load your codes. Your interface can still be Jupyter, and Jupyter can also feed into the SAS Studio, and any kind of machine learning that you wish to do, it can be done. So typically this tool, it looks like a typical analytical tool. So let the tool be there. You can try the link that I was referring to, and you can simply log in there, have your credentials done, and see for yourself how does it looks like. Meanwhile, the tool comes in. Let me show you a quick piece of SAS Wire. How does it looks like? So just watch this. You would have an understanding.
My name is Xiangxiang Mo, Senior Product Manager for SAS Visual Statistics. Today I'm going to share a demonstration of the Python interface of SAS Visual Statistics to analyze a customer attrition data. SAS Visual Statistics 8.1 is based on SAS Wire and SAS Cloud Analytics services. It provides different programming interface for you to call the underlying SAS analytic actions. The languages we support include SAS, Python, Lua, Java, as well as RESTful endpoints. Today I'm going to focus on the Python interface and demonstrate it in a Jupyter notebook. Let's take a look. The Python interface to SAS analytics capabilities called SWOT, SAS, scripting wrapper for analytic transfer. Just like using any other Python package, you first need to import the SWOT package. In this demonstration, we assume you already have a running SAS server and you have the right authentication to connect to that server. Therefore, you only need two pieces of information to set up a connection from the Python client to the SAS server, the host name and the port number. Now we have imported the SWOT package and set up a connection. Let's look at what's in the server. A SAS server contains analytic and non-analytic action sets. An action set contains one or multiple SAS actions. We can actually use a SAS action called action set info to see which action set has been loaded. As you can see, these are the action sets preloaded to your section whenever you start a new connection. We can use the help function to get more information. For example, let's take a look at the simple action set. As shown in the output, simple action set contains SAS action for basic data exploration and data summary. For example, summary statistics, Pearson correlation coefficient, one-way or two-way frequency tables, and so forth. Now, let us move on to the fun part. Let us analyze some data. First, we need to know what datasets have been loaded to this server. We can actually use the table info action to take a look. You can see 3 tables has been loaded to this server. Let's focus on the dataset called attrition. This is related to whether customers of a telecom company want to cancel their subscription or not. This type of activity is usually called churn or attrition. To use a cost table, first you need to create a reference to that table using the cost table method. Just like CON as a local reference to the remote cost section, data1 is actually just a local reference to the attrition table in the cost server. We are not moving or downloading the data. The simple action set provides several useful actions for data exploration and data summary. For example, let's get the summary statistics for all the numeric variables in this dataset. The table displayed here is actually a pandas data frame. If you program in SAS language before, you know that the result tables from the SAS procedure are SAS ODS tables. In this new Python interface, all cost actions generate pandas data frame instead. Therefore, you can work with cost action results just like working with a pandas data frame. For example, you can use column indexing to subset the output table. Given the cost action results are native data frame, you can actually use any other third-party Python packages as long as they support pandas data frame. For example, you can use the freq action to generate a frequency table, and then use the bokeh package to render the bar chart to take a look at the customer attrition rate. Next, let's try to build some models. Logistic regression is one of the models available in SAS Visual Statistics. The model is actually in the regression action set. You need to load the action set before you use the model. Once the action set is loaded, all the actions in the action set are automatically attached to any cost table object. For example, you can run a logistic regression model as a method on the data1 object, and the minimum set of parameters you need to specify are the target variables and the predictors. So far, we displayed all the outputs for cost actions in a Jupyter HTML format. The SWOT package also provides a render HTML method to render the output in a SAS HTML format, which is actually very similar to the ODS output in a SAS environment. This demo provides an overview of the Python interface of SAS Visual Statistics. We hope you enjoyed it. Thanks for watching.
So guys, this was something on the interface that we have, and that's how the integration happens. So the link here is you can just simply type in Google via developer and get a free trial of SAS and Python integration. And Python coders, I think you can try this. It's going to be a great experience. Now, of course, if some of you are new to machine learning, SAS provides the Data Science Academy, which you can visit on the link that you have. We have lots and lots of courses on big data, artificial intelligence, and advanced analytics, which includes machine learning. In fact, doing a SAS course will fetch you a digital badge, which you can showcase in social media sites and all that. It's digitally verified, internationally acclaimed badge, and it has got links to several of the job offers that we have. In fact, in the Data Science Academy, much of it in the level 2 is dedicated towards machine learning, be it neural network or any other kind of technique involving text analytics, time series modeling, experimentation, and optimization. Most of it, the best of the machine learning algorithms, is what you're going to get to learn here. We have mapped each course to the skill set that is required as per the MIT Sloan report and McKinsey report of skill sets that somebody needs to build in. So a lot of this information is available on those links that you can leverage for your benefit. At SAS, we provide a lot of individual certifications, boot camps. So my advice would be to take the SAS survey. So let me just take you through very quickly of what are all the things that we're doing. So this is our SAS website for the Data Science Academy. And in that academy, as you can see, all the details that I was talking about, it's there. You can take a free survey here, and we would be more than happy to guide you what your learning skills and requirements are. We do these trainings. We have a lot of boot camps on machine learning. And if you visit the site, the links that we have on SAS training offerings, it has all the details. And there is a survey that you can take this out and get a feedback on in terms of your learning requirements, your career that you want to pursue, and how you can take best of both the words like Python and the SAS. So that is something from my side. And what I would do is I would stop here for a while, and I would be more than happy to address your queries. So you can raise whatever questions you have.
Hi, can we please launch the two polls before we go on to the question answer?
Yeah, so yes. So let's have a quick poll, and then we'll start the Q&A session.
The result for the first poll is displaying on your screen. Sunil, do you have experience on SAS tools? So 12% people are saying yes, and 88% people are saying no.
Yeah, fair enough.
Yeah, I'll launch the last poll for the day.
Right.
The results for the last poll are displaying on the screen. Sunil, what is your preferred mode of training? So 39% of the people say self-paced, 25% say instructor-led trainings, and 36% people say live web trainings.
That's great. That's great.
So now we move on to the Q&A part. I would like to tell all the attendees that if you have any questions, kindly keep posting them on the questions panel on the GoToWebinar control panel. We are awaiting your questions. In the meantime, Sunil, you can take the questions which are already posted on the questions panel.
Yeah. So let me go to my Q&A panel. So I can see across that there are quite a good questions that I have. So some of the questions let me address. So I think I'll read the question first so that everybody knows what the question is, and then I'm gonna give the answer. So one of the questions goes like, what are the limitations of open source tools that make SAS to be still a preferred tool? And the guy who has asked the question understands that the cost is not an issue with the open source, but why there are a lot of organizations which are actually still using SAS. See, one of the things that happens, first of all, it's a matter of choice and the size and the scope of the company, what kind of an IT strategy you want. Typically, the companies would go with SAS, they're large size corporations, and they have respect for the IP and the knowledge that get developed. Several other things like, as I said, SAS would have service level guarantees that are given. We test our algorithms on the standards of worldwide testing that are there, alpha, beta, gamma, different levels of testing, and that testing is not the technical side, which open source would also have. These checkings are based on the deployment servers, the high-speed test, and the verified hardware and the software. Apart from that, issues like cybersecurity, they're all well maintained with a commercial tool like SAS. And then there are other arrangements like, the kind of heavyweight analysis that it can do with the speed. So terabytes of data getting analyzed in fractions of second, that too, with the given set of hardware. These are some of the things that makes SAS still a choice for a large number of companies, as you might see. Let me take into another question. So one of the questions is for the ML beginners, as you got a SQL basics, what path is easy, whether it is SAS or whether it is Python? Now, since you have SQL, SAS has its own proc SQL. So SQL guys, the SAS journey gonna be relatively far more easy as compared to Python. Now, the reason being the technical side of it, Python has data frames and the concept, whereas SAS treats the database as a typical database in any SQL kind of an environment. So the journey would be easy, but remember we are moving towards a no SQL or not only SQL kind of a thing. And SAS has something called as DS2, which can query large big data on systems like Hadoop, Spark, and many others where there is a seamless connectivity. So my suggestion would be to have preferences. If you're a SQL guy, for that matter, the journey with SAS is going to be easier. Nevertheless, nobody stops you from learning the Python. So there are a few other things, how to avail machine learning courses from SAS website. So you need to go to the links I was showing, and there are appropriate surveys, people to contact. So that is what you can do. See, some of you have asked for the software access. So simply type SAS University Edition free download. You can download and try. There is a free SAS Wire trial that allows you to integrate your Python machine learning knowledge into the SAS world. All you have to type it in the Google, the right keywords, and you can get the access of the SAS software sitting at your home. Now, there are a few other questions like which language is best suited to learn ML? So the answer is it's your choice that you want and how you prefer and what your background has been. In fact, you have seen in SAS that machine learning can still be done even without the programming language if you wish to. So it's a choice. If you are from the business side of it and you somehow are either scared or hate programming, you can still do everything using SAS tools that you have. And you're saying what are the one of the questions talks about what are the specific tools to write machine learning algorithms. So the answer is Python, yes. R, yes. SAS also, the answer is yes. It all depends on what kind of preferences you have, what kind of training and flair for programming you have, and accordingly you choose a language that best suits you, and that's how you go ahead for taking a decision where to write machine learning algorithms. As you've seen, SAS, the single platform wherein you can write a Python code, a Lua code, a C code, or a Java code, or anything else. So that way you can marry all the possibilities into one single platform called SAS Wire, and you can see more details and the free login access onto our website, and that's how you can start your journey. Another question that keeps on, I think this question gets on getting repeated most of the time in most of these webinars. What are the jobs that will get lost due to the result of machine learning revolution? Answer to this question is, see, the jobs never go away. If you see highly advanced automated Western world, which are technologically driven, unemployment is not a problem there at all. Unemployment is a problem with most of the developing countries where pace of the skills that is required is not matched with where the market is moving. Thanks to the opening of the economy in India now, I can work for Google sitting in India, I can work for Facebook, and you will be surprised if I share the data. Most of the time, the machine learning algorithms, the analytics actions for most of the famous companies are happening in India. You name a big bank, maybe Barclays or RBS, you have things in Bangalore who are writing and doing machine learning for them. You name retail stores like Target, we have analytics centers in India. So most of the time, any revolution now happening in the West, you have people working right here in India, and most of the time they work from home also. So that is the opportunity that we are talking about, and we upgrade. So whenever there is a technology shift, we all have to do is to upgrade. Of course, if you do not upgrade, I still, let's say I stick to Fortran. That's how my journey started in programming. Fortran is no more, so I moved on to C. When C, there was a lot of saturation, people moved on to SAS, Python, and all that. So you have to evolve. In this field, if you want to stay, you have to be learning new things all the times, and that's how typical IT or a programmer guy is. So keep that in mind. Jobs will increase, different types of jobs will come. Now you see there are jobs which talks about maintaining data for the machine learning, writing algorithms for the machine learning. So universities, professors, several people, there are people who are doing deployment, who are doing consulting in the area. So new era of jobs are unleashed. So if you upgrade, there should be no fear about the job loss. So there are, so there are questions like, is there any community edition available for SAS Wire? Yeah, you can just type in SAS Wire free access or a demo access on the Google, and you get links from our SAS website. You can register there and you get your SAS Wire for free. It is integrable already. The Python integration is there. You try your Python codes, write to it, see how the machine learning can be done. In fact, if you know more languages like Lua or anything else, you can try them over there. So it's always there. Let me also see some of the questions. So one of the questions, I think it goes like this: how can I choose a right model by seeing a data set? If I have to answer it, you see, you don't put a right model by seeing the data. What you have to do is you have to deploy a host of machine learning algorithms and the models onto the data. And then you have to pick up what is the best. So in my webinar also, when I had that organics data demo, I deployed a decision tree, neural network, and then I deployed a regression. And then out of these three, what was best in validation? That's what I picked. Similarly, when I was showing Python integration, I used Python random forest from ScienceKit package. For R, I used the random forest function coming from the random forest package. I use SAS HP forest. Out of these three, I saw which is the best and I'll use. So there is no way that you can say that this particular algorithm is suitable for that. Of course, there are general guidelines. If your dependent variable is categorical, you might want to use a logistic regression. If it is continuous, then it becomes regression. So there are generic rules available. But beyond a point, let's say neural network, it can take any kind of dependent variable. So you have to deploy it, figure out how its performance is, and then take it from there. So the answer lies in finding it out and discovering. For every problem, there are a host of models available. We try all of them and do it. Now, if you're doing it on a product like SAS EMinor, it's simply a drag and drop, and within half an hour, you can try as many as 100 models to it. If you're a coder in Python, I mean, you have to write that much of a code. So as I said, the speed is the differentiator for SAS, and that's how if a typical Python deployment starting from end to end, though the cost might not be there, but time to make it functional, if it is 1 month, if you're on SAS environment, it's hardly be a day or two. So you save time up to the magnitude of 1 by 30 or so, or more than that, and that is money. So that's how the cost of SAS gets also justified, because you save money on the time side of it. You deploy faster, you stay ahead of your competition, and that's where the advantages are. So you need to understand that. So that's great. Now, let me see. So there's a question, can we write Python code in SAS window, or we can call Python scripts? So see, you can call Python scripts from SAS EMinor as I was showing you. Another demo on Wire, we were calling Python codes from the SAS window. So that is very much possible. Of course, there are prerequisites. Same machine should have Python deployment and SAS deployment so that SAS and Python can communicate with each other. And you issue commands and run your Python codes from there. And as we are moving, we are trying to move more and more Python capabilities to SAS. And that's where when the SAS itself, you will be able to write the Python code and run it. No need to further give an external call to Python. So that's how. Now, there are a few more questions. Whether SAS is a query or a coding language. See, SAS is a mixture. SAS SQL is the querying language. Base SAS coding is an object-oriented programming language. You can do whatever you like. SAS DS2 allows you to query data stored in Hadoop Spark, so it's a big data language as well. SAS SCL, you can develop applications, menus, and everything. So SAS is not a single language, it's a collection of different concepts of the language put together as a single language, and different people use it for different purpose, but largely the syntax remains the same, and that's the beauty. So I have used SAS language not only to write SQL codes, but to write DS2 codes, that's for big data. I have developed applications. I have in fact written music symphonies also. You can create music in SAS. There are music functions and the sound functions available. You can create graphics also, dashboards also using SAS code. So there is, the sky is the limit. So much to be explored over there. So I will suggest, once you go to the SAS website, start searching that, you would come to know more about the SAS language. So now there are questions, I think, which are going like, how much of a time or effort is needed to learn a tool like SAS or Python? See, it all depends on your learning spirit and the speed with which you learn. Now, if you are talking about SAS, I can be sure, because we have a training program that spans within 6 days to a full data science program, which could be 6 months. So depending on your learning need, people I have seen learning SAS within a week as well, and becoming a data scientist and a machine learning expert might take between 4 months to 6 months. That is how our academy courses are designed. Until now, whosoever has gone through the Data Science Academy, they have successfully completed it, and they're employed in respected companies. We have seen people starting from scratch, from a manufacturing background, and now they're doing pretty well. But then they had the willingness to learn, and they were ready to spend a lot of time. So I think these are some of the questions that I could read through and I could answer. I think there would be a few more questions which we can think of, can be shared over a mail, and I would be happy to provide the answer to. I think we are nearing towards 6 o'clock. So let me scroll through. If the time permits, maybe 1 or 2 questions. Otherwise, we'll be closing the webinar. Let me just check it. There is a question I think I want to answer. It's coming. If you want to predict, can I choose 3 models at a time? Yeah, the answer is you can not only 3, you can take 100 models at a time. In fact, all 100 of them predict, and you can ensemble them. So if it is a classification problem, you can go by the voting logic, or you can take average of all the 100 models and see how the results fare. That is called ensemble modeling technique. Or combined model, and it is very much supported in SAS EMinor. If you're on Python, you can write an appropriate code for that. In fact, random forest is just a development from the same concept, that why not use several models and then combine the output into one. Just the mechanism should be right, that how do I combine the predictions, whether do I take the average, or do I take the max of every model, or do I go by the voting if it is classification criteria. So that is what we call ensemble modeling, and not only 3, you can deploy as many as models you want and just combine them towards the end. And in SAS EMinor, there's an automated node called ensemble node that you can use to do that. And some companies in fact do that, and sometimes ensemble model becomes the best model because when you're doing voting, you get best predictions from each of the model, and best of the best becomes the best. That's a possibility. It again all depends on the data and the nature of the problem. Difficult to generalize, but people do try ensemble modeling from time to time. Well, that's great. So let me quickly see 1 or 2 questions. I think we are about to be touching the closing time of the webinar.
Hi Sunil, if you could repeat your email ID, a few attendees are interested in mailing you some queries.
Okay.
So
Great. So what I'll do is, let me display my email ID, and I would be more than happy to reply to one of the specific each of you, the specific queries you have. I'll share the links and the knowledge from where you can get the info. My email ID would be here as displayed, sunil.bharadwaj@sas.com. I have a full team here which can support you, so I might redirect you to some of the best minds. Let's say some of the questions were on the training side of it, so we do have a full-fledged education training department which can answer your queries. Most of the technical queries myself and my team can handle, so we will be more than happy to reply to you. Please feel free to write whatever comes to your mind, and we'll be more than happy to acknowledge that.
Thank you so much, Sunil, for this really empowering and motivating session today. And I would also like to thank all our participants for making this webinar a great success. This session has been recorded and the recording will soon be available on techgig.com. Thank you everyone for joining us, and a very special thank you to you, Sunil.
Thanks once again. Thanks you guys sparing your time. It was really nice answering questions. I'm looking forward for more. Thank you.
Have a good day. Thank you.